Hey guys, I'm Nick and welcome back to the new tutorial. Today we're creating this kinda rust sandblasting effect, which was initially inspired by this one of the latest man with machine works for Nike, and especially this effect where it's kind of like laser beam that removes the previous version of that shoe. And majority of these things could be used in tutorials, but today we are focusing on that thing with the rust removal. And I think maybe I will do another version for this tutorial, because today we are not recreating this one like one-to-one. We are using a bit different technique, but yeah. Also wanted to give credit to Alex Cotterill Drew, who created the model that we will be using today. It's this Tissot Couturier watch, and we are using just that part of it, as you can see in the preview. But yeah, let's go inside Houdini and see what we got here. So let me first of all save this project. The setup for this one consists basically of three parts. One of them is our watch, and it's the top part. Another one is watch bottom, which does not play any role in the simulation. It's just there to fill the composition of the frame. And then we have another geo which is called particles. And these are all beautiful flaming particles that are bounced off from our metal watch bracelet. And also we have a camera, and also we have the RS light dome. So these are the nodes that we will need. Let's maybe start creating our watch, right? So we have the alembic in the resources. You can see here, if we click on this little icon, you can see that I have all the folders here, and now I want to go into the resources, and here we have our watch top. And this is the top of our watch. This is the bracelet, and we'll be working with this one. So I have made a few adjustments to this mesh because it was AutoCAD. I actually needed to kind of quadri mesh it, but quadri mesh for this one, it wasn't the best way to make it smooth and also keep this logo here. And so that's why I just VDB'd that model. And yeah, now you can see it has UVs, it has fairly large number of polygons, and for this effect I would say you need a pretty dense mesh. In this case we are talking about like roughly 1.5 million primitives. We import our watch here, and basically we can drop the null already and call it out collider, because we will be using this one as a collider for our particles. So my main idea was, whenever the point bounces off from the surface, we mark that area with another color, and then we will have some sort of a mask that we can use to transition from one texture to another. So right now we need to kind of create something that will emit all these millions of particles, kind of the nose of our sandblaster. So what we can do is drop this grid, make it 1 and 0.3 as I did in my previous version, and here you can see it. Yep, that's our grid. Probably wanna template this collider to see what's where, and I think we will need to make our grid a bit smaller, so should be something like 0.3, maybe like this. And also we can offset it a bit so it's perfectly centered with our collider, like this I would say. And of course make it like 0 point something like this maybe. And now we need to animate that collider so it goes over our watch wristband. So let's go and add a transform here after the grid, plug the grid into the transform, and now we want to select the kind of initial state. So let's check our bracelet once again. So here's our Tissot, whatever. And I wanted it to go from this point here to this point here. So let's just for now drop a merge so we can see both of these. Merge, merge. Now we can see both of our collider and kind of emitter grid. And here in the transform, I can move it up, move it up, yeah, like this, I would say, maybe a bit higher. Yeah, and then what I want to do is to move it in the Z axis like this. And now maybe move it down slightly. And now also I wanna rotate it. You know what will be easier for us if I just drop the poly extrude and drop it here. And let's set the distance to be 0.1, like the default. And what I can do now is go into the 1, 2, 3, 4. Yeah, 4. 4 is the right viewport. Now I go to the transform and I press enter. And now I have this a bit more convenient control over the rotation of this grid. And what we will do, we will just like disable the poly extrude once we don't need it. But for now, I just want to make sure that I position it correctly like this. I want to like 90 degrees angle here, and I think it works. So this is good. This is done. Then at frame 70, no, at frame 150, we want to set it to be in its final destination. So let's move slightly out, zoom out, and then hit enter again. And here we can rotate it again to something like this and move it back to here. Maybe we will need to rotate it again a bit more. So yeah, I think like this. So rotate and translate, keyframe that, and you can keyframe it just holding in my case it's Option. I think on Windows it's Alt buttons. You can just hold Alt and click and we'll add keyframes. And here at frame 90, or no, actually 75, yes, but want to move it up a notch like this. I don't want it to be visible actually. So again, Alt and click on Translate and rotate, and you will create these keyframes. So yeah, I think everything is pretty good. Maybe at 150 we wanna make it a bit higher like this. So yeah, we have done the base of this emitter of the particles. So we don't need poly extrude. Now we can set up the pop network. How we can do that is just by clicking tab and we start typing pop network. Here it is. Plug the transform into the popnet and immediately you will see something interesting. So yeah, if I play it now, like nothing happens, just a bunch of points emitted and they stay in the place because there are no forces that actually are applied to these particles. So what I want to do is make these particles move down, like if they would be like blasted from that device. Basically attribute wrangle, and we can visualize here on the transform. Let me just visualize the normals. Now you can see the normals. Basically I want this direction but in reverse. So I can say that at v velocity equals minus at n normals. So now if we go to the pop network and I can uncheck this normals, now you can see that woohoo, it works. Look at that. Yep, pretty cool. So for our pop network, let's go and set up this kind of like thing with the collisions, and also in the source first input we can like immediately go to the burst impulse activation and set it to be at not at but actually $F, it means frame, less than 150. So we don't need to emit particles after the frame 150, and somehow it doesn't work. So it turns out that you also need to let a constant activation to that same thing, and it wasn't like that in the previous versions of Houdini, I assume, but yeah, that's strange. But anyhow, impulse activation, constant activation, everything is set to 0 after the frame 150. What do we need to set up here in the pop solver? I think everything is default. You can go with the min and max subsets at 1, just 1. And yeah, static object, it's basically our collider object. We can go and grab static object, merge. We can then select these pop solver and static object and just plug them both into the merge. And then remove this pop solver to output connection and put the merge into the output. For our static object, so here we go to the subpath and we find our out collider. And this is basically what we need. So for the collisions, I'm using surface collisions, nothing too fancy, but now you can see that it will become pretty slow. You probably want to visualize it. Let's escape the simulation and yeah, just run it once again. So yeah, let's check how it looks at frame, I don't know, maybe 60. Yeah, so because this collider has too many polygons, the Pop network and the Pop solver, it actually takes a lot of time for it to calculate. But basically you can see here that it works as expected. The particles being launched or bounced away. You can see here there's some sort of this weird looking layering or some rows. But yeah, I don't think that we should be worried about that. Yeah, it looks pretty good to me. What we will need to do else is add pop collision detect. And collision target is our sub, and subpath should be our out collider. We can bypass this use deforming geometry because our geometry is not deforming actually. Uncheck this guide and go into the behavior. And what I want to do is put all the particles that hit the target, put those into the group. And we can name a group like blasted or I don't know, whatever. But this will be a group which stores all the particles that have hit this shape here, our collider. Also, I want to add some pop drag, and I don't know, do we need wind? I don't think that I have actually used any sort of wind, but yeah, again, you know what, after this one, just go to the sub level. In the pop network, we want to delete this shift 8 sign and select pop object here, only these particles here, and let's go and file cache it out. Let's use for now just like 30 frames or something, and constructed, no, we want to go explicit geo tutorial 1 and hit save to disk. Yeah, cool. Now we have our 30 frames, and look at that. This works pretty good. Works pretty cool. I think maybe I need hit this preserve group, because yeah, if the group isn't preserved, it is cleared out first, so the only particles in the group will be those that just hit. Nope, we need to hit the preserve group here. And maybe let's add just a bit of wind, and also, so yeah, pop wind, like just a bit, like 0.03. And for the source first input, I definitely want a more on these points, like 50,000, and I want the life expectancy to be anywhere like 0.4, and this is in seconds, right? So if 1 second is 30 frames, 0.4 will be like 12 frames or 13 frames, something around that, and life variance could be at 0.2. So now I also maybe want to set this velocity to be a bit more, so they like really bounce off from the collider, because right now you can see it's more like they bounce off, but I want them to really freaking explode everywhere. Let's try and file cache it out with the new settings again, 30 frames. And this also doesn't look right to me. Turns out that we need to go into the static object and use solver default here in the collision detection, because somehow surface collisions, I think it actually uses the volume collisions and tries to create the VDB from this shape. So yeah, use solver default is what you want to go with in the collision detection. And now if we save these 30 frames, it will again be a bit faster, I think, than the surface collisions. So let's see. Yes, this definitely was way faster, and you can see the result is just as we want it to be. Yeah, pretty good result. We have everything, every point that actually hit the target is red, and they're flying away in all directions. Yes, this is basically, yes, absolutely the thing that we need and want. So yeah, maybe I would like to cache out a bit more frames. Let's say at least 75. And yeah, let's just hit save to disk once again and cache out these 75 frames. This actually took me just something under 2 minutes, so pretty fast. Yeah, so we still have a bit of this stepping or layering. I think we can go with a few more substeps in Pop Solver. So max substeps at 3, min substeps at, I don't know, maybe 2 will be good. And yeah, let's simulate again 75 frames. Now this took a bit more time, but I think the result is also a bit better. Now we will work with transferring, or actually like cleaning our rust from the points where our particles hit the collider. But before we do that, let's drop a null and call it out particles, so we can work with them in another geo node when we will be setting up the shaders, colors, all that stuff for them. But right now, let's drop a delete node, the textile density, but delete. And we want to delete everything which is not in the group called blasted. So we want to delete non-selected points. So basically we're deleting everything that is not bounced or not hitting our collider for now. And for the color, let's go with white color, I assume, or no, actually red color. Not sure if it's actually the red color. Yeah, I think it's actually the red color, so we can delete our color node and drop another one for the collider. So this one should be black, and then we can create our attribute transfer and plug this color into the left input, plug this delete into the right input. And here for our attribute transfer, we can go with in the points, which transfer CD attributes, right? And for the conditions, we can go with distance threshold to be 0.001. Yeah, like this. And blend width at a 1. Nope, at, yes, I think 0.01. Yeah, sounds good to me. Yep, this looks like the thing that I want to see. All right, maybe blend width could be 0.015. Yeah, like this. Yeah, this is better. So then what I want to do is add a little attribute blur. Actually don't know if we need it, but let's bypass it for now and let's add it if we actually will see any, you know, the blank spots, the rusty spots after our sand has gone through this. Now we want to somehow keep that color attribute, right? And I've used this technique from Terranimator, and I will link his video in the description. But this is a very clever way to actually keep the attributes that are kind of moving across the geometry. And we need to drop this solver here, and here we need to use a switch. So let's go back into the solver and hover over the start frame, right click on it and select copy parameter. And here in the switch, what we need to type here is if $f is more than, and now paste relative references 1 and 0. So if the frame is more than 1, which is our start frame, we will grab our previous frame. And if not, we will use the input 1, which is current frame. And then after the switch, we drop attribute wrangle and we plug our switch into the first input or zeroest input, and previous frame goes into the first input, like after the switch. And in attribute wrangle, Terranimator actually uses really clever and really simple logic. So what we need to do is grab the color of the point at the previous frame. So previous color data is 0.1, because we're gonna grab it from this previous frame, right, which is first input, not zeroest. And color data is the thing that we grab from all the points, and we reference these points with pt_num. And then we just compare if current frame CD red channel is basically less red than previous CD X, which is same as R and X, because RGB XYZ. If that current frame red value is less than previous frame red value, we basically set it to be the same as it was in the previous frame. So if that's true, CDR equals to pref CD X, and it should work right now. Let's check. Yes, here you can see how our red is growing, kind of similar to all these growth algorithms, you know. But yeah, let's go back to the solver, and yeah, this basically, this is done, right? We have something right now to actually go between two materials. Let's just go back to the solver. After that, we can file cache it all, file cache. Let's drop, yeah, the same 75 frames, I assume, or 70. How many it was here? 75 actually. And geo to 275 at solver, save to disk, and this will be pretty quick one. So 9, 10, 11, 12, blah blah blah. Yep, almost done. So here we have our solver cached out, and yeah, it looks pretty good and goes pretty well till the frame 75, till the frame that we have cached it out. To create something similar to my initial setup, I need to add a few translate nodes, transform nodes actually, to turn it around and yeah, adjust the rotation so it gets into that same angle as it is in my demo version. So in my case, I'm translating it by 0.9 and rotating it by -180 in the x-axis, and then I apply another transform, and again 0.9 in the y, -128.1 in x, -27 in y, and -26 degrees in z. And yeah, this looks pretty familiar to me. I was rendering like this, I think. Yeah, something like this. All right. Then I know, do we need to blur our attributes, like the color attribute, or not? I don't think so. But one thing I know is we need to remap our red and black colors to white and black, because Redshift won't recognize red. So attribute wrangle. Here are the tricks. So basically, our CD is equal to the CDR, so yep, cool. So basically, yeah, CDR is either 1 or 0, so we are mapping, and if we are mapping vector to float value, we are setting all these 3 vector values to the one float. So basically it's 1, 1, 1 or 0, 0, 0. And 1, 1, 1 is white and 0, 0, 0 is black. So yeah, I think we are good. We can drop the null and call it out watch. Cool. Officially we are done with this one. All right, we need to add the bottom of our watch. So I know that I will need these two transforms here. So let's go into the watch bottom and let's drop it in alembic. This alembic, we can go and select watch bottom, and here we can convert it back to the polygons, and then we drop these two transforms and boom, it works. Kind of works. Yeah, I think it works. So we have our watch. Let's set our camera to be, what do we need here? A resolution 1080 by 1920, focal length to be 80. I know, probably can set up the materials, I assume, right? Oh, our slide dome. Enable and viewport should be unchecked. Texture, brown, photo studio, saturation 0. For the transforms, I was using 30-degree rotation for the Y and 60-degree rotation in the Z. And let's add new pane tab type and select the Redshift render view, and let's just see what we got. But before that, we need to actually adjust our camera so it shows us at least something, right? So I think it should be like that. Yeah, with the focus on this logo here. Let's go back to our Redshift tab and hit start stop IPR, and boom, we crashed. You can actually, or maybe it's on a Mac, but I can click somewhere and then click Control or Command S, and you can see here that it says successfully saved. So now if I close the Houdini, we still have the saved version. And now we can see that we have our watch. Let's zoom out a bit like that. For our RS light dome, let's go into the light and go to the environment and uncheck that we want it as a background. So now we will be rendering it with alpha. And I want to start applying my materials. So let's go to the material network, drop it here, and let's create a few materials. So RS material and redshift material as an output. It goes here, and let's call this watch material. Let's now go back to our watch top, and you can both select them, watch top and watch bottom, or no, probably watch top, only watch top needed. And here in the render tab, we can go here and select in our material network our watch material. And let's go back to the material network and let's start dropping out our textures. So RS texture, we drop 1 second and third, and also we'll need normal, or nope, actually it's called bump map, RS bump map. Here in the bump map we can already set it to be tangent space normal, and high scale should be 0.2, I think. Connect that third one to the texture input. Output goes to the overall bump input. Our second texture will be reflection roughness, and our first texture will be in the diffuse color, I think. Yeah. All right, so these, let's go one by one and apply textures. So this one should be metal iron 5, I think. So base color goes here. We might need to actually restart the render, so start stop IPR and see, maybe, yep, then it applies the correct texture here. For the roughness, we want to select again the roughness texture, and color space should be raw here. And yep, it works. And for the last one, which is normal map, let's go select metal iron 5 normal, and again color space should be raw. I think, yes, this looks good. We could maybe go with a preset, change it to iron, but then we are losing this diffuse. And let's set the diffuse to 0.8. Now for the reflectivity, this Fresnel type should be metalness. And reflectivity, we could plug this texture sampler, this iron base color, we could plug that into the reflection reflectivity. Yep. And then metalness, let's set it to 1 maybe. Yep. Yeah, I think this looks good. So we have ourselves a really rusty metal. So let's call it metal rusty. And now I want to create another material, which is our not so rusty metal. So let's just copy these and call it metal clean. All right. So let's plug it into the watch material for now so we can see what's going on. So for this texture sampler, which is our base color, we want to go with the metal iron 3 and here select base color. For the roughness, we want to do the same, but yeah, again, go to the metal iron 3 and select roughness here. And don't forget to change the color space to raw, because when you change the file name, the color space somehow gives back to the sRGB. And for the bump map, actually, yeah, let's go with this metal iron 3 and normal map, and then again change it to raw, but I want it to be very, very subtle, so high scale as 0.05. Yes, this looks good to me. All right, now we want to use our color, particle color or point color, to actually blend between these two materials. So let's go with RS point attribute here, and let's drop material blender, RS material blender. Now I want to select my metal rusty, which will be our base material, and plug that into the material blender base material input. And then metal clean should go into the layer 1, here layer 1, layer color. And particle attribute lookup, its attribute name is set to CD by default, so it's good. And out color goes into the layer 1 but blend color. Now let's save it so it doesn't crash and plug this output into the surface of our watch material. And now we want to start and stop our IPR and hopefully we will see that blend between two materials. And look at this, it works. We have the remaining rust here. The way to kind of remove it from this is to make our emitter a bit wider than the watch, but to be honest, I think it adds the realism actually, because we are blasting only this top surface here. So for our bottom watch, we can go with this metal rusty, create another material, call it bottom watch material, and plug this out color from the metal rusty to the surface of this bottom watch material, and then go to the watch bottom. Here, go into the render tab and hit the material bottom watch material. And if I restart the IPR, you can see that we have this part rusty as well. For our particles, let's go and make them look like fireflies or something. So object merge here, object one should be our watch top out particles. And because we applied transform to our watch, we actually need to apply that same transform to our particles. So copy these two transform nodes and apply these here to our particles. We can stop the IPR for now so it doesn't eat our resources of my laptop. But yeah, then we basically split it to the two streams. One is our, and we split by the group blasted. So here will be on the left side will be all the particles that are in the group blasted, and here all the particles will be the ones that are not in the group. So we can colorize both of them differently, of course. These particles that are probably when I switch to the scene view. So these particles should be black. We don't need them. And the ones that are in the group that actually bounced or hit our target, we can go with color type set to ramp from attribute. And attribute could be age. So age here goes from 0 to 0.6 as average, and I want to go with a Inferno, but reversed Inferno. I think this will be looking pretty good. And then we merge both of these, so we will have some particles that are just black and some of them are bounced from our collider. So yeah, like this. Let's go back into our particles. Let's go into the Redshift OBJ tab on the particle geonode, and let's go here in the particles, render object as particles, global scale multiplier 0.02, I assume will be enough. We can check how it looks right now. It might not look that exciting, you know, because it's actually a lot of post-processing things here. But I think, yeah, it's not that bad here. Let's go and assign some materials. So RS material and then Redshift material that serves as out particle material. And for this material, what I want to do is add a bit of roughness. And for the color, I want to go with RS point attribute, which is set to CD, and attribute name. And this CD attribute actually goes into the emission color, not into the base color, but we can also plug it into the diffuse color as well. And here in the overall, for the emission weight, I want to go with something like 50. And then, yeah, I think we are good. Let's assign this material to the particles, go into the render material and particle material. Let's save it and refresh our IPR. Yep, this looks pretty good to me. The only thing we need to do is to apply lots of post effects and motion blur. So let's go to the out node, Redshift ROP1. Let's go to the Redshift. Mode should be set to advanced. Into the motion blur, enable motion blur, deformation blur, instances, particles blur, enable everything. And let's go back to the OBJ. Let's go to the particles and Redshift OBJ settings, mesh deformations blur from velocity attribute. Let's again refresh our IPR. This looks a lot better. Looks a lot like a fireflies. Maybe we should change the coloring from this Inferno to black body. Could be better. Again, reverse it and see what we have. And this actually actually looks a bit better than the previous option with the Inferno. I think I will go with this one. And now it's just a matter of applying a lot of post effects. So let's for now just hide our particles. We don't need them because we will be setting our bokeh. Let's click on this bokeh here and then click on this icon here, and now click on something like this place in the frame, and you can see we have a lot of depth of field. So after that I want to set the photographic exposure. For the color control, so I want to up the contrast just a tiny bit and maybe up the exposure too, so we really have this rust, like really prominent rust. And after that I wanna actually enable my particles back so I can see the bloom. Yes, this is good. Oh yeah, this, you see, it already is much better. So bloom intensity not that much, and bloom threshold probably a little higher. Then of course some flares like this, and maybe streak. Yeah, some streaks decrease the intensity just a bit. So this looks much better than it was without these post effects. So this is without post effects, this is with post effects. So I think it's pretty obvious. Maybe decrease the exposure a bit, and actually to make it, like realistic, you should decrease exposure once these things hit our metal, because the camera will be kind of adjusting the exposure. But yeah, I think we are good, guys. This is it. This is our final result. And yeah, of course we can render, for example, frame 45. We will need to stop and start IPR once again. Now here you can see how they travel, these little thingies travel through the holes in the chain of this bracelet. But yeah, overall I think that's it, guys. I think that this looks pretty beautiful. I think that's it, guys. I really hope you enjoyed this tutorial and you learned a few new cool tricks that you will be using in your commercial and personal projects and any other projects. I'm really grateful to every one of you who is supporting me here on Patreon. I'm doing my best to stay consistent with my tutorials. I try to answer all of your questions and overall provide the best service I can. So if you have any questions, hit me up in the Discord or send me an email and I will get back to you as soon as possible. And of course, I will be back next week with a new tutorial. Bye!